I think there'd been some interest in trying to branch out beyond the IBM setup. I know that a few people here are interested in Microsoft's offerings, and also I thought this would kind of help influence where the group might go on a kind of medium to long term basis. Given that it's kind of a the direction of the group is up to the group. It's not up to any individual one of us. So this is a good opportunity, I think, to for me to kind of run through some of the things that I've seen and get some feedback. So what I've been looking at mostly has been around the kind of vendor independence frame of things, rather than one specific vendor's offering. Obviously, we've been using IBM's Qiskit software, but Rigetti offer Pyquil, Microsoft offer Q#, and so forth. It'd be quite nice to see what offerings are out there which cover more than one vendor or more than one language. So that's what I've been looking into. I'll stop right there before I kind of dive in and share my screen. But is that something which is also of interest to the group we have here right now?
I'm seeing some thumbs ups.
Oh, super! I like thumbs ups. All right. Well, I mean, I guess if that's kind of clear, I'll try to share my screen and see what happens. I think I will need to have my screen sharing enabled, please. I think what I'd also like to try to promote or provoke, I guess, is some discussion from the rest of the group as to what they really feel their pain points are when they've been either going through the textbook or they've been going through code in their own time. That'd be really very nice. So I will just hang on a minute. Let's just share my screen here. Right. So stepping back a little bit. I think one of the initial goals of trying to bring people together was to get a sweet spot between inclusiveness and generality, and principally Qiskit has been a good choice to satisfy this, partly because there's lots of learning material and a relatively large community. It's also Python centric, which is a relatively friendly language, as you all know. It's good for kind of quickly getting up and running versus some other offerings. And it's usually helpful, if you're having other people look at what you're doing, to have a language that they might be able to grasp pretty quickly. And then the other part was that IBM have made it pretty easy to gain access to some of their smaller machines as well, which is obviously vital if you're looking at playing around. Downsides, of course, which I think I've heard from some other people, is that the Qiskit language is fairly low level, in the sense that I think people are interested in getting some higher level abstractions. My own personal view, I would argue that it isn't necessarily a bad thing to have a low-level language, a gate-level language, rather than say a kind of provided function for doing, I don't know, amplitude amplification. From the point of view of that, given the high level of noise in this kind of current era, working with at least understanding the individual qubits is very, very useful, and particularly for optimizing circuits, and then also optimizing for empirical noise. Can obviously be the difference between running a meaningful experiment and not running a meaningful experiment. And I think the other main downside is that it seems, from what I've seen, that for obvious reasons, Qiskit is largely natively limited to having IBM Quantum as a backend. I know that people are keen to be able to make use of a large array of machines. So I'll so in principle, you can kind of get around some of this by, one, just writing your own high level functions, although, personally, I'm not experienced enough in understanding the transpilation phase. That's a phase that goes from the physical to the logical qubits, to understand, the drawbacks and how difficult it is to write fairly general high-level code that works across machines. My suspicion is that in some cases it's probably quite difficult. So I'll kind of move on to some of the things that I thought I'd highlight. So on a strictly kind of coding Python API level, these are the document pages for tket, which is Cambridge Quantum Computers offering. And I've opened it up specifically on one of the pages. So what they try to do under the hood is they try to optimize circuits to some degree with regards to the noise of that the circuit will generate. But the other nice thing that they offer, that they seem to offer, are some tools to try to convert circuit languages between each other. So here we've got a conversion between the tket API here, and having this kind of ability to convert between languages, it seems to me to be quite useful if you're talking to other people and they're using Qiskit, but you actually would prefer to, in your own time, code things up in a language which is more suitable for you. If we kind of scroll down on the side here, they have a whole slew of extensions here with which to translate between languages as well. Now, it doesn't end there either, because one of the nice other things that they've provided natively are a set of backends for actually accessing different machines. So in principle, you could take your Qiskit code, you could take your Qiskit code, you could translate it into tket in an automated fashion, just a line, and then you could run that on another machine if you had access and had reason to want to do that, which is pretty useful, right? Because that means that you can simultaneously take advantage of the the interactive development tools that IBM offer for putting together circuits and understanding them. Now, of course, there will be drawbacks to this, as even in the documentation, it admits that it's not the whole kind of circuit optimization and circuit compilation problem isn't one which has a a single solution. So this seems like it's interesting to play around with. So that's from a kind of a Python coding perspective. And I'll stop for 2 seconds before I move on to a more kind of visual perspective as well. Okay. So I think another one which I found which was interesting. So I'll move on to things with a a kind of a graphical user interface here. I'm not covering the entire universe. These are things that jumped out on me. There are some parts of the software universe which are on the list to explore and potentially interesting. So this is a dashboard and a setup offered by Strangeworks. So what's quite nice about this? Okay, so let's just immediately create a project. Call it my temporary project. You can obviously interface with a repository you're using, or you can just kind of clone from a set of libraries that Strangeworks provide. And then once it's hopefully run things up. All right, okay, great. So create a project, add files, and then I will notice that there are these framework templates over here. So for example, if I click on Q#, it will create a Q# a notebook with Q# code to get started running immediately. And it won't be code that really does anything, of course. It's a nice little touch that demonstrates how easy it is to get started on and get exposure to different languages on this on this front end. I think it's still taking a bit of time to get set up. How about I go backwards, not wait for that, and let me see. Oh, another one that I call delete. Yes, that makes a lot of sense. This one I'm hoping will load at least a little bit more quickly. And it's probably my internet connection. Ah, okay. So here's something in Python that was just created immediately to get people started. It gives them it gives people just the initial incantations to write a small circuit with a measurement and send it to a simulator. But of course, they have other offerings as well. They seem to offer connections to a range of different backends. I think Amazon Bracket themselves, I think their offering also has connections to different vendor backends as well. So bit of a nested thing going on there. And then I think they've to make a and so forth. So this was quite a nice neat little front end to gain exposure to other parts of the ecosystem. So I thought that was really nice. So I'll stop there for a moment. There were a couple other visual front ends as well. Quantum Spire, that one I wasn't able to get credentials for, so I can basically go off of this picture, and that's about it. This is Q Control's offering, and what's kind of this is something which I'm looking into exploring a bit more, because they make a point of, first of all, offering a lot of potentially interesting visualizations, but also focusing on noise characterization as well. So I've probably spent about 5 minutes looking at this one, so I can't really say much more about it, but it's something which I think is I'm intrigued to take another further look at as well. And then I think finally there's Zapata's Orquestra code. Now this is a little bit different to what's been shown before. In fact, this is very different, because what Orquestra is effectively, it's you give them a file with some specifications. So this is a configuration file. You tell them what to import. You use this file to say which outputs of what file go into which outputs of another file, and which jobs get run on which machines. So it's in many ways it's the opposite of a GUI. It's just specify a configuration and let it run. And this is quite interesting for me from a point of view of because personally I like to be able to standardize my workflows where possible, and that includes when I'm learning something from scratch. Part of the battle is figuring out what does a workflow actually look like. If I want to understand something, or if I want to start playing around with something, how do I understand the steps going from an idea to understanding its limitations. So this was quite interesting, and you can run this if you get an Orquestra account. I haven't got one just yet, but it's for me this is a very interesting idea. And I think that's more or less where I got to from the perspective of different ways people have looked at providing multi-vendor, multi-language access to the quantum machines.